Basically, what I would like you to do is to make an observation about what happens, and let's just choose the zeros first, because I think there were two problems where when we solved b squared minus 4ac, both of our, we ended up with two zeros, and you make an observation about the roots. Or how many roots did you get? One root. Okay? So what happens when we ended up with a positive number? And that's what we're looking at. We're looking at that they're positive as opposed to what the value is. But this is a positive, this is a positive, and this is a positive. What happens? You have two real numbers as a solution. So we had 1 plus or minus. Is this a real number? It's a radical number, but I know I have a real number there. And let me see, 256 was 6 or negative 2. They're both real numbers. And when it was 25, it was a negative 3.5 or negative 1. Everybody good with that? So when we have a positive, we have two real numbers, two real roots. And what about when we have negatives? So, okay, we have complex conjugates, okay? And that's what you need to know, that these will be complex conjugates. And we had talked about complex conjugates once before, and I know that if I had minus 9, and I'm just going to write plus I rad 7, and this is over 4, do you remember what I meant by the complex conjugate? Anybody remember? So we talked about it earlier. Okay, well it is. The complex conjugate is the same number, only it's minus 9. It becomes the opposite of that. So if I asked you, what is the complex conjugate of this? The answer would be minus I rad 7 over 4. And I told you that when we are dealing with rational expressions, that this is going to be very handy because we're going to be able to eliminate our I. So we're going to be squaring things, and that's why we use a complex conjugate. Does that ring a bell? I talked about that a while ago. Okay, so when we have b squared minus 4ac, and we end up with a negative number, we end up with, and the answer here, actually we're going to write this down, is complex conjugates. Okay, so if I look over here, I had a negative 2 plus 2i, or it would have been a negative 2 minus, there's a 2i over here. Okay?
What about the 3 plus I and the 3 minus I?
Those are the complex conjugates, 3 plus I, 3 minus I. I'm just changing the sign before my I. Okay, so let's just please make sure that you write this down in this section. So in this case, we had a negative 7. We ended up with two complex conjugates. When it's 0, we have one real root. When we had a positive number, we're going to have what? Two real numbers. When it's, and it just repeats it. And I'll give you some notes in a second.
Why did they say two real numbers, not two real roots?
It is two real roots. Roots are the solutions to, we will end up with x.
Yeah.
Right. Yeah, it should be two real roots.
Doesn't really matter, it means the same.
Right. Two real roots. Okay? All right, so if you want to take out your little folder, I'm going to give you some words. Actually, let's take out our graphing calculator before we move on. And let's grab the first three problems. Okay, so number 1. All right, so for y equals, let's go with 2x squared plus 9x plus 7. And just graph it. So we're just graphing that first. And mine looks like this. So what do I need to do to my window? Okay, so I'm going to go to zoom what? Zoom 6. And do we have 2 real roots?
Yeah, we do.
Okay, everybody have that?
No, I can't see the equation.
Well, the equation was on the worksheet that we had from last night. So it was, I just did the first one. 2x squared plus 9x plus 7. And I can see when I graph it, what are my roots. I can see that it is a negative 3.5, and I believe it was a negative 1. And that's what we're looking for. Okay? Is everybody good with what it looks like? Let's try the next one. So you're going to go back to y equals, and this one is 2x squared plus 9x plus 11. When I graph that, is it touching the x-axis?
No.
No. Does it have 2 real roots?
No, it's complex conjugates.
They're real, they just don't cross the x-axis. Why don't they cross the x-axis?
Because they cross the
Okay, think about when we graphed complex numbers, okay, we had our imaginary numbers. Okay, and so we have our real numbers, and this isn't crossing the real numbers, right? Because doesn't the x-axis represent the real numbers, but it has zeros, and those zeros happen to be what? They happen to be complex conjugates. It doesn't cross the real numbers. Does that make sense to everybody? Eli? Yes.
So wait, it crosses like a Z axis?
Yeah.
No, not a Z.
I thought it was like a third axis.
No, that's when we were talking about, when we were solving equations for, with 3 variables, 3 unknowns, we had an x, y, and a z. Okay, this is our, we graphed them on a different plane, and this is the Cartesian coordinate plane, and we used the complex conjugate plane. Okay, so it is not crossing the real numbers. So it is an imaginary number.
What's it crossing?
Well, it's,
An imaginary thing.
right, it's an imaginary number. Okay, which would be, where am I? Sorry. Okay, so it's telling us, and I'm not sure where it is, but it's crossing, but it's in the complex, it's in here. Remember, we had, these were our real numbers and these were our imaginary numbers, and it's crossing in this plane. Okay, so what is the number for this one? It was at, when x was a negative 9, so it's going to be someplace in, when x is a negative 9, it's crossing, well, it's not on this window because this isn't at a negative 9, but it would be crossing up here
So
somewhere.
some things can't be solved by graphing, but they do have a solution.
Yeah, yeah. Okay, and then let's just do this last one, x squared minus 6x plus 9. And that one is x squared. X squared. Okay, and so what did we say that this one had? When it was equal to 0, it would have 1 place, so it is touching at, at 1 place. Now, we're talking about quadratics, and so what we say is, when we are dealing with quadratics, we like to say all quadratics have 2 solutions, and we say that it is a double root. Now, I'll give you that number, even though it would be For both solutions, it would just be x is equal to 3, but it's called a double root. Okay. All right, so everybody understand what we have here? We have the discriminant. It has a special name. You should know that word to your vocabulary. And you know what? This will be it for our quadratic. So if you're almost finished this section, we'll be going on to conic sections and other types.
So that will be in this book.
No,
Can you put it in this book if you have a lot more room?
you may, if you have room. Okay? So the discriminant, and that should be underlined. So the discriminant of a quadratic equation is b squared minus 4ac.
What does it mean?
What does it mean?
It's just, oh, it's, okay, it says it.
Okay? Why was that helpful? We just did this whole chart.
Yeah,
What did the value tell us? Tells us about its solution, right? So we were able to make an observation that when it is positive, when our answer, whatever comes out with b squared minus 4ac, if it's positive, it means what? 2 real roots. And if it's negative, we have 2 complex conjugates. Okay, it has a value, it's just not on this plane, and I forget the name of the complex conjugate plane name. And when it's 0, we have 1 real root. So you should probably just draw the little sketch. Can I just move this up for everybody?
Is it b squared or negative?
It's just b squared. Formula was b squared minus 4ac.
Well, you tell us about what?
Just tells you about the solution. It gives you information about the solution.